It's that course again, and in this video we'll be looking at the types of oxides. First and foremost, what are oxides? Oxides are binary compounds of oxygen, a compound that has two elements, in which one of the elements is oxygen. You call them oxides. There are four major types of oxides. We have the basic oxide, acidic oxide, neutral oxide, and amphoteric oxide. I use mnemonics to call them BANA. B for basic, A for acidic, N for neutral, A for amphoteric oxide. What are basic oxides? They are oxides of metals that react with acid to form salt. Those are basic oxides. They react with acid to form salt. Basically, basic oxides are insoluble in water generally, but there are few of them that dissolves in water, and these few basic oxides that dissolves in water, we call them alkalis. So alkalis are soluble basic oxides because most of them are not soluble. So bases are oxides of metals, but the soluble ones among them are called alkalis. Examples of basic oxides are potassium oxide, magnesium oxide, calcium oxide, lithium oxide, calcium oxide already repeated, copper 2 oxide, sodium oxide, and any oxide of metals that exists. Now, when the metal is a group 1 element, they are usually soluble in water. Like potassium oxide, potassium is a group 1 element, sodium oxide is a group 1 element, lithium oxide is a group is an oxide of group 1 element. So they are alkalis. They are soluble in water. Alkalis, alkalis, alkalis. Also, calcium oxide, barium oxides, all those elements in group 2 apart from magnesium also form soluble bases. So you call them alkalis. So acidic oxides, these ones are usually oxides of non-metals, unlike basic oxides that are oxides of metals. And this acidic oxide dissolves in water to form acidic solution. Almost all acidic oxides are soluble in water, and when they dissolve in water, they turn the water to an acidic solution, and sometimes and also they react with bases to form salt. Examples of acidic oxide: phosphorus oxide, nitrogen 4 oxide, sulfur 4 oxide, sulfur 6 oxide, silicon 4 oxide, carbon 4 oxide. They are all acidic oxides, and you call them acid and hydride. Acid and hydride because when you put them inside the water, they turn to acid. For example, CO2 inside the water gives you a weak acid, H2CO3, and CO2 can also react with a base to give you a salt and water only. So CO2 is behaving as an acidic oxide in this reaction because it's reacting with a base to give us salt and water. And you can see SO3 reacting with an alkali. Bases, soluble bases are called alkali. So it's form a salt and water also. So SO3 is behaving as an acidic oxide. Here they dissolve in water to form acid. Here they react with bases to form salt and water. So in both cases, they are acting as acidic oxide or acid and hydride. You call NO2 a mixed anhydride because it can form mixtures of two acids in water. In this case now, NO2 plus water gives you HNO2 and HNO3. So it's a disproportionation reaction. So the NO2 disproportionates in water to give you mixture of two acids, HNO2 and HNO3. Can also react with a base to give you mixture of two salts. Like in this case now, it's giving us KNO2 and KNO3. So is also a mixed anhydride in that kind of reaction. So in general, two oxides, acid metal oxide, they are basic oxides. In water they form hydroxides, and then non-metal oxide are acidic oxide. In water they form acid solution whose pH is less than 7. So let's move on. What are neutral oxides? Neutral oxides are always oxide of non-metals that are neither acidic nor basic but are neutral to litmus. They are not acidic, they are not basic, but they are neutral to litmus. Examples of those neutral oxides are H2O, that's water, CO, carbon 2 oxide, N2O, nitrogen 1 oxide, the one you call laughing gas, then NO, nitrogen 2 oxide. So all these are neutral oxide. They are not acidic, they are not basic, but they are neutral to litmus. So let's see amphoteric oxide. The word ampho is coined from the word amphibian. Amphi means two things. They are able to behave as two things. Like the word amphibian, able to live on land and on water. Amphoteric oxide also can be an acidic oxide and can also behave as a basic oxide. So they are oxides that exhibit both acidic and basic properties. They react with both acid and base to form salts. That is acid amphoteric oxide. An example of amphoteric oxide are beryllium oxide, BeO, tin 2 oxide, SNO, aluminum oxide, Al2O3, lead 2 oxide, PbO, zinc oxide, ZNO. And I abbreviate them as B-TALs, where B stands for beryllium, TALZ, in that order. So they are amphoteric oxide. They can react with both acid and base to form salt. So that's why you cannot transport acidic material or basic material in any metal that is made up of beryllium or tin or aluminum or lead or zinc oxide. So when this amphoteric oxide reacts with acid, they form normal salt, like we have in this case. Zinc oxide is amphoteric oxide. With H2SO4 and acid, it forms a normal salt and water. So here is behaving as a basic oxide because it's reacting with an acid to form salt and water. Then when they react with a base, they normally form a complex salt. Like in this case now, ZNO reacts with sodium hydroxide, that's an alkali by base, in presence of water to give us tetrahydroxozincate 2 compound of sodium. That is, it gives us, this compound is called sodium tetrahydroxozincate 2 salt. It's a complex salt. That's what happens when zinc oxide reacts with alkalis in the presence of water or any amphoteric oxide whatsoever. That's what they form. Peroxides are actually not major type of oxide, but they are higher oxides. Higher oxide in which oxygen exhibit an oxidation number of -1. So in peroxide, oxygen always have oxidation number of -1, unlike -2 that is supposed to have in every normal oxide. And what makes them have the oxidation number of -1 is because of an oxygen single bond that is present in peroxide. Examples of peroxide are hydrogen peroxide, H2O2. How do you know a peroxide? A peroxide always have one oxygen more than a normal oxide. A normal oxide of hydrogen now should be H2O. You can see that. But now the O has increased by 1, H2O2. It has become a peroxide. A normal oxide of sodium should be Na2O. You know sodium has a valency of 1, oxygen valency of 2. So when you cross their valency, it should be Na2O. But now we're having Na2O2. That means having one oxygen more than a normal oxide. That gives us a peroxide. So this is a sodium peroxide. In the case of barium oxide, barium has a valency of 2, oxygen valency of 2. So it should have been 2 cancel to 1 1. It should have been ordinary BaO as a normal barium oxide. But if you look at it now, it's BaO2. That means it's having one oxygen more than a normal oxide. So it becomes a barium peroxide. In the case of calcium peroxide, it's supposed to be calcium oxide, CaO. But since it's a peroxide, it must have one oxygen more, that's CaO2. So that is how you distinguish between a peroxide and a normal oxide. In peroxide, oxygen there has an oxygen number of -1 as opposed to -2. And the number of oxygen in a peroxide is always 1 more than a normal oxide. So you can produce hydrogen peroxide when you react dilute acid with metal peroxide. We'll look at that under hydrogen peroxide. So these are the types of oxides that we have. God bless you.